Select the major product of the following reaction. So if we look at our starting material, we can see that we are starting with a secondary alcohol, and we are treating this with sulfuric acid. And sulfuric acid we know is a strong acid. And we are heating this up. So all of these pieces of information should combine to let us know that this is going to be an E1 reaction. So the unimolecular elimination. So what we need to do here is, first of all, to take this alcohol, which is a poor leaving group, and transform it into a good leaving group. And that's what the role of the sulfuric acid is. So if we have sulfuric acid and we have an alcohol, the first thing that's going to take place is an acid-base reaction. So this is a reaction to kind of get this molecule set up to do the elimination reaction. So your alcohol can act as a base and take a proton from the sulfuric acid. And what this is going to do is it's going to convert this from hydroxide, which is a really poor leaving group, to a neutral water molecule, which is an excellent leaving group. All right, so we have this protonated alcohol, and when that leaves, it'll form a neutral water. So if this is an E1 reaction, that means that this is going to be the stepwise elimination. So your leaving group is going to leave, which is going to generate a carbocation. So there is the carbocation that is generated. And we always want to look carefully at carbocations to see if they can rearrange. So we started with a secondary alcohol, and we call this secondary just to reiterate this in case we need a refresher. The carbon that the alcohol is attached to has 2 bonds to other carbons. So that's why it's a secondary alcohol. And then after that leaves, we're going to get a secondary carbocation. And so carbocations can rearrange to become more stable. And we've got these 2 methyl groups on the adjacent carbon. So if we shift one of those methyl groups, what we will do is we will end up going from a secondary carbocation to a more stable tertiary carbocation. And then from there, this is as stable as this carbocation can get, we can have the elimination reaction take place. So you need to eliminate a hydrogen from the adjacent carbon to your carbocation. So we have hydrogens here, here, and there's 1 down here. We know there's 1 there because we can only see 3 bonds to that carbon at the start, which means there is a hydrogen there. If we remove the hydrogen from that center, that's going to give us a tetrasubstituted alkene, and that's the most stable alkene that this carbocation can form, and so that's what's going to happen in this case. So with an E1 reaction, you're always going to form the most stable alkene product that you can, and so in this case, it will be this tetrasubstituted alkene, which is option B.